Next topic is matrix representation of system of linear equations. So there are two types of system: non-homogeneous system and homogeneous system. So what is the difference between non-homogeneous system? So this is the general form of the non-homogeneous system with m equations, linear equations, and n unknowns. So a11 x1 plus a12 x2 plus a1n xn is equal to b1. Similarly, the second equation and third equation. So there are n unknowns. So what are that? X1, x2, xn. These are unknowns, are constants, and the number of equations are m. This is the first equation. This is the second equation, and this is the mth equation. So this is the linear equation. All these are linear equations because the powers of x, these unknowns is 1. uh, Power of x1 is 1, power of x2 is 1. So the notations for unknowns are x1, x2, xn, or we can use the notation for unknowns as x, small x, small y, small z, small w, and the constants are denoted here by a11, a12, a1n, a21, a22, a2n. These are constants. Okay. So if all these b1, b2, bm are 0, the values of b1, b2, bm is are 0, then we say the system is homogeneous system. Okay. Or if out of these b1, b2, bm at least one is non-zero, then system is called non-homogeneous system. So this is the general form. So we can write this system in the matrix form. So the non-homogeneous system first, we will write it. It is in the matrix form. So write the this is the matrix one matrix, and this is the another matrix of constants. And then we can write this as a multiplication of these two matrices: a11, a12, a1n, a21, a22, a2n, and am1, am2, amn, and the x1, x2, xn column matrix x1, x2, xn. And this is the column matrix b1, b2, bm. So we can write we can denote this matrix by, suppose, capital A, this capital X, and this capital by B. Then where A is what? A is this matrix, that is, and B, X, capital X is this matrix, and capital B is this matrix. So X is equal to B is the matrix form of the system. So if the system is homogeneous, then obviously this matrix, column matrix B uh, contains all the entries are equal to 0. That is 0, 0, 0, 0, column matrix. Okay. So this is the matrix form of the system of linear equations. So we can write a matrix form of every linear homogeneous as well as non-homogeneous differential equation. Okay. Not differential equation, non-homogeneous equation. Uh, then this matrix, that is the combination of this matrix A and B, is called the augmented matrix. It's called augmented matrix. AUGMEN TDED, augmented matrix. So the combination of we can denote the notation for augmented matrix as a square bracket or round bracket A, line or oblique B, then square bracket complete. So this is the notation for augmented matrix. That is the combination of A, the matrix of constant, and the matrix of coefficient. This is the matrix of coefficient, and the matrix of constants. Okay, so the combination of these two is called augmented matrix of the given system. So this is the system of homogeneous system of linear equations. This is homogeneous system, and this is the matrix form. It's matrix form. Ax is equal to 0. Okay, and the non-homogeneous system, it's matrix form. Okay, so in the non-homogeneous system, this column matrix A is 0, and obviously A0 or AB as a matrix, coefficient matrix, and all the entries in this column are 0 in the homogeneous system. Okay, so consistency of the system of linear equations. So when we say the system is consistent, if system has one or more solutions, then we say the system is consistent. Otherwise, we say the system is inconsistent. That is, if the system either homogeneous or non-homogeneous has at least one solution, then we say the system is consistent. Otherwise, we say the system is inconsistent. So, when we say the system of non-homogeneous system is condition. So condition for the consistency of non-homogeneous linear system. So if rank of A and rank of AB, that is rank of the matrix of coefficient, is equal to rank of the augmented matrix. If these two ranks are same, then we say the system of non-homogeneous system is consistent. That is, if the rank of the coefficient matrix A is equal to the rank of augmented matrix AB. If these two are same, then we say the system Ax is equal to B is consistent, or we say has a solution, possesses a solution. Okay. Then what is about a homogeneous system? Homogeneous system is always consistent. Homogeneous system is always consistent. That is, the inconsistent word is not applicable for homogeneous systems. Because if we observe the augmented matrix for homogeneous system, then it is A0, A oblique 0. Okay. So this is the matrix A, and last column is the all the entries in the last column are 0, and therefore if you find the rank of A and rank of AB after after converting reducing this matrix to echelon form, then we observe that rank of A and rank of A0, that is the rank of coefficient matrix and the rank of augmented matrix in case of homogeneous system are always same, and therefore the homogeneous system is always consistent. Okay. So when the non-homogeneous system is consistent, so if the rank of A and rank of AB both are same, and suppose it is equal to R, then non-homogeneous system Ax is equal to B is consistent. Rank of A. So this is the notation for rank of A, row A, or write rank in bracket A. So rank of A and rank of AB both are same, and it suppose it is equal to R, then we say the system of non-homogeneous system is inconsistent. And if rank of A and rank of AB are not equal, then non-homogeneous system is inconsistent. Then this non-homogeneous system has a unique solution if rank of A is equal to rank of AB, that is R is equal to number of variables in that system. Okay. So rank of A and rank of AB are equal, then non-homogeneous system is consistent. And if it is equal to number of unknowns, xn, what is xn? Xn is the number of unknowns in that system. If all these three numbers are same, that is rank of A, rank of AB is equal to number of variables, then system has unique solution. System has only one solution. And if the rank of A and rank of AB are equal, but it is strictly less than number of variables, then system has infinitely many solutions. Then system has infinitely many solutions in that case. And in the case of rank A is not equal to B, in that case, the system has no solution. System has zero solutions. So homogeneous system is always consistent. Only there are two cases now. In for homogeneous system, there are only two cases. The system is always consistent, and so the system has either unique solution or infinitely many solutions. That is, in the case of non-homogeneous system, the number of solutions are either 0 or 1 or infinitely many. But in the case of homogeneous system, the system has either one solution or infinitely many solutions, because the homogeneous system is always consistent. Every homogeneous system has at least one solution, and when the system has unique solution, if rank of A or rank of A0 or AB is equal to number of variables in that system, then system has unique solution. And if the rank of A and rank of AB are equal, but it's strictly less than number of variables in that system, then the system has infinitely many solutions. Okay, or is called non-trivial solution. So the solution in the case that rank of A is equal to number of variables. In that case, the homogeneous system has the trivial solution, unique solution, and the trivial solution. Means the what is the solution of that system? Homogeneous system, that is the values of all variables are equal to 0. That is, suppose x1, x2, xn are variables, then the values of x1, x2, xn are equal to 0, and is called trivial solution. That is, if you observe the homogeneous system, then if you substitute x1 as 0, x2 as 0, xn is 0, then first equation is satisfied. If you substitute x1 as 0, x2 as 0, xn as 0 in the second equation, then it is also satisfied. So if you substitute x1, x2, xn are 0, then all the equations are satisfied, and therefore x1 is equal to 0, x2 is equal to 0, that xn is equal to 0 is always solution of every homogeneous system, and it's called trivial solution. So other than trivial solution, other than zero solution, we have another solutions are called non-trivial solution. That is, obviously the values of x1, x2, xn are not all equal to 0 in non-trivial solution. So there are two methods to solve the system of linear equations. One is Gauss elimination method. So in this method, the augmented matrix is reduced to row echelon form, and then by back substitution, the corresponding system of equations can be solved. That is, in the Gauss elimination method, uh, reduce the system, write the system in matrix form, and write augmented matrix, and reduce the augmented matrix to row echelon form, or called echelon form, and then by back substitution we have the solution of the system. uh, and in the Gauss-Jordan elimination method, or just say Gauss-Jordan method, or we say Gauss-Jordan elimination method. This is Gauss elimination method, and this is Gauss-Jordan elimination method. In this method, augmented matrix is reduced to reduced row echelon form. So in the Gauss-Jordan method, uh, write the matrix form of the system, and then reduce the augmented matrix to reduced row echelon form, and then by using that reduced row echelon form, find the solution of the system. So the difference between Gauss elimination method and Gauss-Jordan elimination method are what? In Gauss elimination method, reduce augmented matrix to row echelon form, and in Gauss-Jordan elimination method, reduce the augmented matrix to reduced row echelon form. So the examples, the first, write down the system in matrix form. So this is the system, obviously non-homogeneous system. So we can write the matrix system in the matrix form as Ax is equal to B. So what is A? A is 2, 2, 2, minus 2, 5, 2, 8, 1, 4. And capital X is what? X1, X2, X3. The unknowns, either the unknowns, the notation for unknowns are x1, x2, x3, x4, or x, y, z, w. Okay, and the matrix of constant is 0, 1, minus 1 column matrix, and the augmented matrix is this combination of A and B. So this is the augmented matrix EB. So for this system, okay. So write down the corresponding system of linear equations from the augmented matrix. So we are given augmented matrix and where to write the system. So what is the system? 0 into x1 plus 0 into x2 plus minus 2 into x3 plus 0 into x4 plus 7x5 is equal to 12. 2x1 plus 4x2 minus 10x3 plus 6x4 plus 12x5 is equal to 28, second equation. That third equation is 2x1 plus 4x2 minus 5x3 plus 6x4 minus 5x5 is equal to minus 1. So we can write from equation we can write augmented matrix, and from augmented matrix we can write the system of linear equations. Okay, so from this augmented matrix we can convert the augmented matrix to system of equations. Okay, so we have to solve the examples by using Gauss elimination method and Gauss-Jordan elimination method. Okay, so some examples on these two methods, Gauss-Jordan elimination method and Gauss elimination method. So question is straightforward, that solve the system by using either Gauss elimination method or Gauss-Jordan elimination method. So first test the consistency of the system. That is whether the system given system is consistent or inconsistent. If the system is consistent, then find its solution. But if the system is inconsistent, then system has no solution. So first test the consistency of the system and then solve the system. So these are some examples on the Gauss elimination method and Gauss-Jordan elimination method. So first example is solve this the system of equations either by using Gauss elimination method or Gauss-Jordan elimination method. We will solve this system by Gauss elimination method. So the matrix form of the given system of equation. So write the system in matrix form. So 3 minus 2, 0. So the coefficient of x is 3, coefficient of y is minus 2, and coefficient of z is 0. So write 0. Coefficient of w is minus 2. And then the coefficient of in the second equation, coefficient of x is 0, coefficient of y is 2, coefficient of z is 2, the coefficient of w is 1. Similarly, in the third equation, the coefficient of x, y, z, w. In the fourth equation, the coefficient of x, y, z, w. And then column matrix x, y, z, matrix of unknowns is equal to matrix of constant 2, 1, 3, 1. Okay, then write the augmented matrix, the combination of A and B. So write A oblique B. Okay. And then the matrix is what? 3 minus 2, 0, 1 minus 1, and then 0. That is, this is the matrix A and this is the matrix B, the combination of A and B. This is the matrix A, this is the matrix capital X, and this is the matrix capital B. So this is the augmented matrix. Now we have to solve the system by using Gauss elimination method. So reduce this matrix to echelon form. So we will reduce the matrix AB to row echelon form or echelon form. So obviously by using elementary row transformations. There are 3 types of elementary row transformations. We can interchange the rows, any 2 rows. Then we can multiply by any number to any row, and we can multiply the any row by any element and add it in previous row or the next row. So there are 3 types of elementary row transformations. By using that 3 elementary row transformations, reduce the matrix, augmented matrix to echelon form, row echelon form. So this is the matrix AB. Then the first operation is R13 because we have to reduce this 3 element to 1. That is either by multiplying any number to this row. If we multiply this first row by 1 by 3, then we have 1 at this place. But we have minus 2 by 3 at this place, minus 1 by 2 at this place. And that is, we have fractions. So as far as possible, avoid the fractions. So in order to avoid the fractions, we interchange the first row and third row. Then we have 1 at the place 3. So interchange the first row and third row, second row as it is, fourth row as it is. So R13, the operation is what? R13. So we have this matrix. Then we have to reduce these elements at this places element to 0. So already at this place we have 0. We have 0 at this place. So we have to reduce this 3 to element 0. So the operation is what? R3 minus 3 R1. The change is in R3. So multiply the first row by minus 3 and add in the third row. So R3 minus 3 R1. So we have 0 at this place. There is change in the third row only. First row, second row and fourth row as it is. And so what we have? Minus 3 plus 3, 0. Then plus 6 minus 2, 4. Then again minus plus 9 plus 0, 9. Then minus 3 into 2 is minus 6, minus 1, minus 7. Then minus 3 into plus 3, minus 9 plus 2 is minus 7. So then the next step is what? Reduce this element to 1. So in order to reduce this element to 1, interchange the first row and second row and fourth row. So interchange the, so in order to reduce this element to 1, we can use the third row, fourth row, but we cannot use the first row. So interchange the second row and fourth row, R24, R24. So we have this first row and third row as it is, interchange the second row and fourth row. We have this pattern. Then we have to reduce this 4 and 2 to 0. So in order to that, we can use this 1 in order to reduce this 4 and 2 equal to 0. So R3 minus 4R1, that is multiply by 4 to the second row and add in the third row. Right? Either this operation as R3 plus in bracket minus 4 into R. This is right, R4 plus uh, 2R1, not R1, R4. This is the R4 at the element 2. So right here R4 minus 2R2 minus 2R2. So right here operation R4 minus 2R2. And then we have the first row as it is, the last row, the second row as it is, and the change in the third row and fourth row. So we have minus 4 plus 4 0, then minus 8 plus 9 is 1, then minus 4 minus 7 becomes minus 11, minus 4 minus 7 becomes minus 11, and then the last row is what? So operation is what? R4 minus 2R2, so minus 2 plus 2 0, then minus 4 plus 2 becomes minus 2, then minus 2 plus 1 becomes minus 1, and minus 2 plus 1 becomes minus 1. Then we have to reduce this element to 1. It is already 1. Then reduce this minus 2 to 0. So the operation is what? R4 plus 2R3. That is multiplied by this element to 2 and then add in this. So we have 2 into R3 plus, that is minus 2 becomes 0. And then minus 22 minus 1 becomes minus 23. And minus 22 again minus 1 becomes minus 23. Then reduce this minus 23 to 1. So the operation is minus 1 by 23 are 4. So the change in only fourth row, we have 1 at this place, 1 at this place. Okay. And if we observe the rank of A, so delete this row, last row, and observe this only, this matrix. So rank of this matrix, so we know that rank of the matrix is the number of non-zero rows in its echelon form. So this is an echelon form of the matrix. This is an echelon form of the whole matrix AB, and up to this one is what? Is the echelon form of the matrix A. So what is the rank of A? Rank of A is 4, because number of non-zero rows in the matrix echelon form of matrix A are 4. This is 1, this is second row, this is third row, and this is fourth row. So in the echelon form of the matrix A, there are 4 rows, and therefore rank of A is 4. And if you observe this whole matrix, then it is a echelon form of, or row echelon form of the matrix AB. This whole is the echelon form of the matrix AB. And if you observe the number of non-zero rows in this echelon form, so there, this is the non-zero row, this is the non-zero row, this is the non-zero row, and this is the last row also non-zero, and therefore rank of AB is 4. Rank of A is 4, rank of AB is 4, and therefore rank of A is equal to rank of AB, and therefore the given system of equations is consistent. Why the system is consistent? Because for the system we have rank of A and rank of AB, rank of coefficient matrix and rank of eigenvalue matrix, both are same, and therefore the given system is consistent. And this number, rank of A and rank of AB, is 4, and in the given system there are 4 unknowns, X, Y, Z and W, and so rank of A is equal to rank of AB is equal to number of variables for this system, and therefore the system have a unique solution, because we know that the system is consistent. Non-homogeneous system is consistent if rank of A and rank of AB are equal, and if this number is equal to number of variables in that system, then system have a unique solution, and therefore this system have a unique solution, exactly one solution, and we have to find the solution. So rewrite the equations. So from this echelon form uh, of the augmented matrix, that is from the echelon form of augmented matrix, from this matrix we have to rewrite the system. So rewrite the system. So x into 1, 1 into x is x minus 2x 2y minus 3z plus 2w is equal to 3. This is the first equation. Then second equation, this into x is 0. So this into y is y plus 2z plus w is equal to 1. The next equation is what? 0 into x is 0, 0 into y is 0. 1 into z is z minus 11w is equal to minus 11. And the last equation is what? 0 into x is 0, 0 into y is 0, 0 into w is 0, and 0 into z is 0, and 1 into w is equal to 1. So we have the four equations. And then by back substitution, we have the values of x, y, z as 1, 0, 0, and 1. But back substitution means what? W is 1, substitute w as 1 in the above equation. So we have z as 0, z as 0. If we substitute w as 1, and if we shift the minus 11 to RHS, then minus 11 plus 11 z is 0. And then the values of w as 1 and z as 0 substitute in the above equation. We have the value of y, it is equal to 0. And then the value of y, z and w substitute in the equation number first, we get the value of x as 1. So we have the values of x, y, z by back substitution. So x is 1, y is 1, z is y is 0, z is 0, and w is 1. And this is the solution of the given system. And it is a unique solution, exactly one solution. The value of x is unique, value of y is unique, value of z and w are unique. And therefore, this is the unique solution. And we can also tally the solution. This solution is correct or not correct. Then substitute these values of x, y, z, w in the given system, right? That is, substitute x, y, z in the first equation, in the second equation, in the third equation, in the fourth equation. So if we substitute x, y, z, w in the first equation, we have the answer 2. If we substitute x, y, z in the equation second, x, y, z, w in the second, we have the answer 1. That is, all the equations are satisfied by these equations, these values of x, y, z, w. And so this we can tally your answer by substituting the values in the given system. So this is the problem on the Gauss elimination method. So if we have to solve the same problem by using Gauss elimination method, then we reduce the matrix, augmented matrix, to reduced row echelon form. So we will see the problems on the Gauss elimination, Gauss-Jordan method in the next lecture.